Let me
Sir,
just...
sige.
Ano yan?
Sir, regarding yung top and bottom na, ano yan, tawag din, yung trace, yung copper traces na yan, pwede bang sa bottom layer yung traces niya? Kasi yung component na i-install mo sa top side, tas i-solder mo sa bottom side, di ba, sir?
Well, parang top na rin yun. So basically, the one that you guys are seeing here, okay, the top one layer is yun yung nasa ilalim. Okay, because the one that, ano ba? Papakita. So this is the top portion of your eagle gun, right? Let's say we have red wires in here. Okay, these are the holes or the pins. Okay, so if you will print this one, so in reality, this is actually the bottom. Bobo ka mag-drawing. Well, sorry for the word. That is actually the bottom portion. All right. Okay, because you will place the component at the top. Okay, like for example, this is your microcontroller wherein it has a lot of pins. Okay, so the wires or the routes is actually at the bottom. Okay, so
Okay, sir. Gets.
I know. Well, you can have actually you can have a layout also wherein top portion only, but your component is at the top of that layout. Okay, so in
Some
yeah,
parts
some
kasi,
components,
sir, dapat i-solder mo lang sa bottom side, hindi mo ma-solder sa top side.
yes,
Diba?
yes, yes, like resistors and yeah, capacitors, LEDs, those components, quasi pins. Okay, so this is where you will solder it, wherein at the bottom side. And then this is the part wherein we have the PCB layouts at the top. Hmm. Yeah. So I almost forgot. Yeah. So you were correct, Mr. Karina. So thank you for that. So some of the components will also overlap, okay, the bottom components because it has wires like this. So that is one thing that you guys also need to consider when you have a bottom components. Like you have a bottom layer right here. So some of them are under wherein you have the capacitor here and then you will put it right there and then the pins will pop out on the top layer. So yeah, you won't be able to solder that one anymore because it's being covered by the other components. So parang ganun. Anyway, so you will realize this one soon as you have the actual PCB design. Okay, because as of now it's just a picture. Okay, so you won't be able to appreciate it unless you do that one on actual PCB. Okay. So me myself, we're only able to do the top layer before. So that is why I don't have any problem, even though I have my pins on the bottom side of your PCB. So all of my components are at the top layer only before on my project on the this subject. Okay. But right now, since we are at the stage of learning, so I would like you guys to experience to have a bottom layer. Though even though this one is much more uh, reliable when it comes to designing, but it's much more a lot of work when it comes to implementing it on a PCB because you're considering two layers, the top and bottom. Anyway, so any other question? I guess all of you are already in here. Any other question or clarification? No.
None,
So
so
guys,
okay na.
Answer.
alright, sige, baka
Answer.
kumakain yung iba. Anyway, so the one that you guys are seeing here, so it seems like they are overlapping, but they're not, since the red one is on the top layer and then the blue one is on the bottom layer. Okay, so this is just a hole wherein you have to uh, put a lead on that one so that they can have a connection. All right, so the next one right here is route clearance. So we have already discussed this one while we are, or while I'm showing the VRC errors a while ago. So just check for clearance error and then just double click that one. And then you will see that it has something like, red teeny, and that meaning the clearance is not good. So just reroute it. You just delete that trace and then reroute it. All right, so the next one right here is the finish project of the this one that we have here right now. Okay, so that's about the simple rules there are. Go ahead and here's something. Yeah, so it is something like this. Okay, once you're done in routing everything. So this one is already a good project where it doesn't have any error. Okay, but that's not the end of it. Okay, so of course, this one's not yet done since we have to add still screen later on. But once you're done with that one, so I would say congratulations, since that's the hard part in designing a PCB. However, okay, let me introduce to you the Autoroute. Okay, so I don't know if you guys have done this one already, but we have this Autoroute in here. So this is a function. Okay, so let me just erase my components to show, not components, erase my recent routed wires. Okay, so we have a fresh unrouted wires in here. So the one thing that we will do is click the auto route. Where is that one? Right here. So auto router. So I would like you guys to do this one also. This is very fun, especially if it was able to design your circuit or your PCB layout properly without having any error. But I doubt that it will not have any error. It will give you a lot of errors actually. Okay, so you can choose the effort in here. Okay, so we have low, medium, and high, but of course you always wanted to go to high effort, okay, of your CPU. Okay, so the maximum number of running threads is 8. Well, if you have a say not that powerful desktop or laptop, you can lessen the threads that is running. But in my case, I already tested this one. So even though my laptop is not that great, so it was able to, route the or my PCB layout properly. Okay. So just click continue, and so by default, so everything is 0%. Okay, it will show you how many percent that's already being covered. So just click start, and it's now starting to analyze and optimize everything. So it is now routing it, okay, by itself with the use of my CPU only. Okay, so I'm not using my mind in here. So I let my computer to do the work. All right, so in that case, I will be able to save more time, maybe. Okay, so this is 50-50. So in here, as you guys can see, we have a 95.5% job that is being done, and the rest are 100%. So the rest that is unfinished, this maybe needs more uh, edit. Oops, I wasn't able to click the end job. Anyway, let's just do that one again. Oops, what happened? Eagle, good board, and save. Save, yes. Okay. Evaluate. Oops, my bad. So there is a component in here wherein it's supposedly at the top one. This one right here. Let me just move this one. All right, so let's do the Autoroute again. Let's see. Yes. 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 Why? Stop. Oh no. Something happened to my PCB design. So I don't know what happened, but my air wires now are gone. And I keep on choosing yes. There you go. You also want to load Eagle project. Yes. All right, so I hope this one now is okay. Okay, let's try Autoroute again. Okay, I will not click that one. I'll click cancel. What? So I'll start over again. All right, so once it's done, okay, let's say everything is already 100%, just click and jump. The one that I did a while ago, that's why we are having an error, is I click cancel or I click escape. So do not do that one. Okay, just click and jump. Okay, and then if you're happy, okay, with the result, then yeah, you can adapt this one, or you can check the errors by going to DRC. Okay, so this is the designs rule check. So again, just click load if you haven't loaded the palette, but since I have already loaded the file a while ago, which is this one start time. So just click check. And as you guys can see right here, I just have two warnings. Warning with wire stub. So meaning, so this is my first time encountering this error. What is this wire stub? Well, uh, I think this is already okay since this is just a warning. Okay, it will doesn't have any error, so we're fine. But let me just try to rip up this one. There you go. I see. So that's just an overlapping routed wire. Okay. So what I did is I just ripped up that that in there. So double click this one. We have another wire stub warning here. So just rip up that one and then remove that wire. So we have one air wire. Actually 19 air wires. We have one error. So let's try to delete and reconnect. There you go. So we don't have any error now. See? So that's the help of Autoroute. Okay. However, okay. However, if it gives you a lot of error, this is actually my first time not encountering any error. Okay. So I was shocked that it didn't give us any error because in my previous routed airwire, it gave me some errors wherein, as you guys can see right here. Oops. Where's that one? As you guys can see right here, the spaces or clearances of my air wires is not that tight. Okay. So one thing that you will be able to know if this is made by Autoroute is if the clearance that is we have in wires is super, super wide, super wide, meaning that is done by human. Okay, and as you guys can see right here, uh, mostly if it's something like this, it is done by auto route function of the EOCAD. Okay, something like this. And yeah, we have some. We don't have actually a VS. So we don't have a VS. We only have a bottom layer, which is the blue one. Okay, so that is also a good thing because we don't need to drill a hole anymore. Anyway, so yeah, and this is perfect. Since we don't have any error anymore, supposedly I will show you to, you know, how to fix those errors if ever we have. But since we don't have any error, then that's it. You're already done. So how about your projects, guys? Have you guys encountered an error when you click the auto router or when you've used the auto router? So
Wala naman,
who's
sir.
here who encountered an error when you've used auto router? None? So that's a good thing. Okay, so you're also lucky if your project right now we're also or doesn't have an error. Okay, when you click auto router. Anyway, so what else that we need to discuss when we're done with that one? Okay, so Rashness. Okay, so we're almost done. So in here, all you need to do is click polygon. All right, so just click this one and just follow the line or dimension that we have in here right now. Okay, and as you guys can see, this is a top portion of your Rashness. Okay. So you don't need to be precise as long as the components is inside of this rat's nest, then that's already okay. Okay, so make sure that you are ending it on the starting point so that you'll be able to close the polygon. So let's name this one ground. Okay, so what we wanted to have is this entire PCB is connected to ground. Okay, so once you're done in rat's nest top portion, okay, I mean polygon, okay, just click rat's nest. Okay, and then it will give you this kind of uh, PCB design. So in here, since our this red one right here is connected to ground already. So one thing that you will notice is the ground pins doesn't have any connections anymore. Okay, because they are already connected with the ground uh, or the red thing in here, whatever is that. Okay, so that's actually a connection. Okay, so this space that you guys are seeing right here is, an indicator that this one is not connected to ground because the entire red is actually the ground. So this is another connection, which is DTR, okay, which is a separate connection. All right. So once you're done with this rat's nest, another thing that you can do is again click BRC if everything is okay. Oops. Then just click check. So it says here, BRC, no errors, left click to start polygon. So it seems that we don't have any error, then we're good to go. So yeah, that's it for the rat's nest for the top layer. So you can also draw another polygon, okay, for the bottom layer. But before that, we have to remove the rat's nest, okay, that we have in here for the top portion layer. So just type here, read up, space, at, and then semicolon. Okay, and then click enter, and then it will remove the rat's nest inside of our PCB. So don't you guys worry, our polygon is still in there. Okay. So just click rat's nest again if you want to check something, and then just type rip up at semicolon if you want to remove that rat's nest. Okay, so the next thing that we need to do is, again, draw another polygon for the bottom portion. So the one thing that we need to check is the bottom layer of your PCB design. Right? Okay, and then we'll also name this one ground, and then click rat's nest. So in here, before we have a line in here for the ground, okay, which is the blue one. But as you guys can see, it is, or the where is that one? The routed air wire is now gone, since it is now connected to the ground rat's nest of the bottom layer. Okay, and then if it's not connected to the ground, then it will also it will still show you, okay, the faded color of that wire, and then their names, okay, VCC, NS4, etc., etc. Okay. So yeah, this is also connected to ground. And then again, just check if there are errors. Check. So DRC, no errors. Left click to start polygon. So once you're done with that, then uh, you're good to go. You may now proceed and start putting some text or labels, okay, or the silk screen that we are calling. Okay, so design rule check. So we right here. So you can download the design rule check that I have. Okay, this one also came from SparkFun. So just click this one. Okay, control left click. It will lead you to their website. I mean, not their website. Okay, it will actually automatically download the file itself. So the name of that one is 52024 blah blah blah. So just move that one. Okay, move that one to the Eagle CAD folder. Okay, so the 9.6.2. Oops. Ayan, yeah. Anyway, I'll just paste it there. And then extract this one. Okay, extract as a folder. And this one. And just double click that DRU. And then this is now the Eagle design rules of this Spark file. Okay. So yeah, just download that one right here. Okay. So any questions so far, guys? Okay, so we're almost done. So this is just the design rule check, blah, 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 whatever that's saying. So just read that one. Okay, so if it says DRC, no errors, then congratulations. But if you have some errors, you have to check those errors. Okay, so here's how I will check your PCB design, your schematic and board layout. So number one, if there are no errors, okay, then that's already 50 points. So it's like 50% perfect already. And then the next thing is how compact your schematic is, or your board layout is. So if you could make this one super compact, like, you know, a smaller PCB, smaller dimension, then the better. Okay. So don't you guys worry, I'm not that harsh when it comes to grading the PCB, as long as I saw that it doesn't have any error, and then the way that you routed your components is very presentable, wherein the ground, I mean the pins or the power jack is on the right placement, then that is already perfect. Okay, so I'm not expecting a very professional design layout, but if you guys can do that one, then worse, that's perfect. So meaning you have a future in designing PCB. And what else? So these are the things that you guys need to know, of course, when it comes to design rule check, clearance, is there components that is overlapping the dimensions, and if there are no errors that's left, etc., etc. So once you're done with that, and what else? Still design rule check. Okay. So this is the Rashness of the top and bottom. Okay. So you will see something like this. Okay. We have the blue one for the bottom part, and then the red one for the top portion. And so in here, if you want to remove the Rashness, so you can click Clip Up tool and then hit the polygon border. Okay. But in my case, I'll always use this one so that I'm not removing the existing polygon that I just draw. So again, just type rip up and then add and then semicolon. In that case, it will remove the rat's nest on your PCB design. And then adding a silk screen. So in here, well, this one is optional, but uh, for the sake of learning, let me show to you guys some of the things that you can do. So let's say you wanted to put your name, who designed this PCB. So just click text, okay? But before that, we have to change this one, okay? So the top and bottom is already in there, the red one and blue one. But the one thing that you need to do is change that one into P place or B place. So P place is for the top portion, okay? And click text. So let's say design by Melpol Saavedra. So it will show you this text, a white text. Well, you can edit this one. Okay? You can edit the color of this text by going back to that key place. Just double click. Oops, doesn't break. Where is the color modification? Okay, wait a second. While I'm trying to figure out how to change the color because it's possible. I think you can change the color into yellow, green, or whatever color you want. Key place. Hmm. All right, so I cannot find it. Anyway, so if you guys were able to uh, find it in the future, then that would be perfect. But yeah, for now, the one thing that I'll teach you is how to change the size. Well, anyway, it's already here. So you can change the size of that text. So you can go to 0.8 to make it bigger or 0.24 to make it smaller, etc. The standard is 0.07. And you can also change the ratio, okay, into, this is actually the thickness of this font style. Well, for you to be able to see the result of this ratio, you have to change this proportional into vector. Okay, so as you guys can see, this one have become thicker. So it's in 28%. I'll make it a little bit thinner. So right there. So we have 11% of ratio. And yeah, so the alignment, so you can, just click, right click of your mouse to change the how do you present it. Okay, or you can mirror it if you want. Just click this one mirrored. Okay, but of course, since you are in a top layer, it should be not be a mirrored function. So yeah, you can do that one. Of course, you can also add more text for the R1. Say this is your R1, and then R2, and R3. So just click escape to go back to the text, editor, and this is your artwork. Right there. So, and let's say one more. See at mel 328. Just put this one right here. So this one now is depends on the designer. So if you want to add some labels, then better. This one is LED1, LED2, LED3, Atmel 328, capacitor, etc., then better. So the next thing that you can do is hit Rashness to see how visible the text that you have put in here. Supposedly, I will change the color of your, the text right here into yellow to make it much more visible. Since yellow is one of the popping colors. Anyway, we have gray in here. I think that's already visible since it's already quite big. And yeah, you can add some text, some shapes if you want, some art, some rectangles, some polygons. You can even add some wires, and those will not affect. Okay, those will not affect your PCB design since those are just text. Okay, so it will be part of the printed part of your PCB. And what else? So this is the result if this is how you want it to be. So we have here the ground, A0, A1, the pins, VCC, etc., with Mega 328. And yeah, so that's how it look like or how a finishing product look like. So as you can see right here, it's overlapping your wires. So again, it's okay. It will not give you any error, okay, since it's just a text. Okay. So it doesn't or it will not affect your routed air wires. Okay, so the next thing that you can do is generate Gerbers, okay, or Gerbers. Okay, so this one is actually the general files that will be generated if you wanted to, submit your design into a certain manufacturer. So for you to be able to generate a Gerber file, is you can click CAM processor. Oops, where is it one? Click this one, CAM processor, and then just click yes, since this is your first time, so it will give you an error. I mean, not error, a warning. Okay, so the CAM output will be based on the save version. So yes, so whatever is this final output of yours will be saved as it is, okay, in a Gerber file. So the next thing that you need to do is load job file and then new cam job or open cam file if you have an existing file. Well, in this case, let's download this one. So we can download the cam file of Part7. So again, just left click and then paste this one onto our EagleCAD 9.6. And then paste it right here. And then extract. So the ending number is C. So that's the one that I'll remember since the other one is also starting with 5. Okay, just open compile and go to that folder 9.6, 9.6, and then this one, and then come, and then that Eagle compound. So just click open. So it will generate the top cover, the bottom cover, the top still screen, the top piece. If ever you have top still screen, that it will also generate a file for that one, etc. So yeah, supposedly there are things that you can do in here, but we don't have enough time anymore. So the quickest way, and since we already have a file, okay, a formatted file by Spark1, so just click process job. So they've already done the job for you. So the same with the DRC check. So we have the file wherein it's the standard format, okay, that is being used right now. So the done the format, and then all you have to do is just click the button. And then, of course, just choose where you wanted to save the files. So let's say in my desktop, and let's say Gerber, generated Gerber. Oops, of course we have to create a new folder, and then generated Gerber. Okay, and then just left click that one, and then select folder. Okay, so just click yes, and then yeah, that's it. So job processed successfully. So you can open that folder, and then you will see here the you will see many types of folders. So we have GBL, GBO. So we have their meanings in here. So GBL stands for bottom cover, GBO stands for bottom silk screen, GBS for bottom solder mask, etc., etc. So those are the things that we'll be needing to submit, okay, to a certain manufacturer. So in other countries, so we have OSH Park, okay, so that is a company wherein they manufacture a PCB design. So just send this generated Gerber files, then yeah, so they will create or they will manufacture your design, your PCB design on Eagle. All right, so we have other companies like Advanced Circuits, Gold Phoenix, Libiada, and many more. Okay, so here in the Philippines, I'm not that familiar yet because the one that we are doing is manual. Okay, wherein we are the one who's creating our PCB. Okay, we don't let the other companies to make our design PCBs in EagleGuide. Okay, so we are the ones going to create it one by one. So we will buy the PCB, and then we're the ones going to put the design layout in there, and then we're going to drill it one by one. Etc. Etc. All right, so we're almost done. So those are the things that could be generated, GPL, etc. etc. And yeah, we are already done. So we still have 1 minute, but that time is not enough. Okay, so I will end our meeting for now, and then we'll just continue the rest on part 3 because there are still things that I need to mention. Okay, I need to discuss. So yeah, goodbye for now, and see you guys on part 3. So if you guys have questions, so just save it on part 3. Okay, so yeah, see you guys on part 3.